Hi, this is Mr. Ward, and I'm going to do a video of some of the problems in 8.1, and I want to deal with number 1 first. So it asks, what is the third term? And you're like, what do you mean by that? Well, go back and take a look in the text, and it gives you a little explanation. So if we have a proportion like this, it says A over B is C over D. Well, A is the first term, B is the second one, C is the third term, and D is in the fourth term. So they are all the positions 1, 2, 3, 4, instead of a backwards in zigzag. They are all labeled there for you. So work out what the third term is based on its position in the proportion. Okay, and then what are the means and what are the extremes? Well, the means are always going to be these, and the extremes are always going to be those. So that is, of course, described in the notes above in the chapter. Okay, number 3, you're asked to work out. So you want to figure out if P is to Q is R and R is to S. Well, one way you could check that out is just see if, so we're trying to figure out if R is to P and S is to Q. Well, they are. But one way you can check that out is get the cross products, get the product of the means and the product of the extremes, and do that for this one as well. Will you end up with the same basic results, an equivalent set of results? So you're going to end up with R times Q here. You'll also end up with an R times Q over here. Well, you end up with a P times S on the other side of the equal sign here. And over here, you'll end up with a P times S as well. There's a way in which this one here has simply been rotated 90 degrees to give us this one. So proportions can be sort of thought of as like in a box, if you like. And if you organize all the pieces, you can rotate it this way or rotate it this way, and you can actually achieve the same basic proportion. Okay, so that will give you what you need. Okay, now I'm going to not do the ones that you are needing to do. I'll do a different one. So on number 4, you're asked to do A and C. I'll do B. So we want to solve for X, and the way we solve for X is this. We multiply 18 times 3 and X times 7. Those would equal each other. Way back in the Wayback Machine, you may have heard of a thing called bat and ball because it leads to that. Okay, so I'm going to end up with 7x equals 3 times 18. And 3 times 18 is going to be 54. Okay, so that's going to be 54 equals 7x. So I can say 7x, and then I can divide both sides by 7, and x will equal 54 over 7. I could go ahead and simplify that somewhat. That would be pull out a 49 sevenths, that's a 7, and then I'd be left with 5 sevenths. So you can leave it like this. The improper fraction is often just fine, especially if you're going to be doing further calculations. But that's what x is. X is 7 and 5 sevenths. On number 5, I've asked you to do A and C, so I'll do B. So what we want to do is find the fourth proportional. So the fourth proportional, so if I did this one, 1, 2, 3, 4, that would be the fourth proportional. So these are in order, first, second, and third. So let's set this up. I'm going to write 1/2 as 0.5 because that'll make my life a little easier. And that's going to be over 3, as 4 is to our, I'll call our fourth proportional x. Okay, so we're just going to do 3 times 4 and 0.5 times x, so that'll be 12 and 0.5x. Okay, because the product of the means equals the product of the extremes. Then I'll double both sides to get rid of 0.5, so x would be 24. So the fourth proportional in that one is 24 like that. Okay, I'm going to pause so I can erase things. And now we resume. I have erased things. Everything magically disappeared. Let's go to look at number 6. So I've asked you to do 6A and 6C. So I'll do 6B. All right, so find the ratio of x to y if these situations exist. So these are, of course, the results of the products of the extremes and the products of the means. So what I can do is I can, it doesn't matter which one I treat as the product of the means, but I can treat this as the product of the means and this is the product of the extremes. Okay, so I'm going to set that up. So if this is the product of the extremes and this is the product of the means, I'm going to set that up like this. So I'm going to say these are the extremes and these are the means. So I will say the first proportional is this one and the fourth proportional is this one, and the first and the second, that'll be the third actually, and that will be the second. Okay, so let me confirm that. 1, 2, 3, 4. Okay, so those would be the means and those would be the extremes. Okay, so I think I have a little bit of an issue here that I need to deal with. What I want to do, since if this is the means, yeah, okay, so that's the means and that's the extremes. I can actually swap this out. This can be 2 and this can be 3. And that'll actually make my work a little easier. It doesn't matter once I've got that set up. So sorry about my terrible 3 there. So that's going to be 2 over 6. And that's going to be, if that's in the 2, and that's in the 3 position, that'll be y plus 3 over x plus 9. Okay, so that's just 1/3. So I'm going to make that 1/3. So what we're saying here right now is that x plus 9 is 3 times what y plus 3 is. So I can actually rearrange this and say, okay, y plus 3. And then I can say, okay, and I'll have an x plus 9. But x plus 9 is 3 times what y plus 3 is. So I can say 3 times that and 3 times that. And I'll end up with something that I can start organizing. So this is going to be 9. And this is also 9. Okay. And so those are going to cancel out. So if I subtract 9 from both sides, I'll end up with just x equals 3y. And now that's a 1x and a 3y. So it turns out that even though we had some extra stuff added here, we've got a 1 to 3 relationship. And, we might have caught that earlier on because that's plus 3 and that's plus 9. So I'm adding 3 and I'm adding 9. So there's a way in which I am adding, so I'm accounting for, I should say, this 1 to 3 relationship. So x to y, the ratio of x to y is going to be 3 to 1. So x to y is 3 to 1. And the way we write that is x is to y as, and that's as 3 is to 1. Okay. Okay, now I'm going to deal with number 11. You're supposed to do A and C. I'll deal with B. So it's asking what's the mean proportional here for 3 and 5. Now, mean proportional is when the means are both the same thing. And that's going to be an important tool for us as we move into the Pythagorean theorem. So I'm going to scroll up and remind you where you would find information about the mean proportional. Here it is. So the mean proportion, also known as the geometric mean, is when you set up the proportion and the means here are the same thing. So that's a is to x is to r, 1 is to 4 is to 16. When you have a mean proportional, when you set up the product of the means and the products of the extremes, you're actually going to be squaring the mean, one of the means. And so the mean will equal the square root of the product of the extremes, which is a convenient structure to work with. So let's see what happens with B. So B is, we've got this pair of extremes, 3 and 5. So I'll say 3 and 5. And we don't know what our means are, but we know they're a mean proportional, so they're the same thing. So that means that x squared equals 15. X times x equals 3 times 5. And so x is going to be the square root. Okay, so x will be the square root of 15. Okay, and I believe it is typical to use the principal root in this case. So you could say negative square root of 15 or positive square root of 15. But if we're just dealing with the principal root, we just say the square root of 15. Now, I've also asked you to do 13, 17, 18, and 21. So 13, we've got the ratio of the measures of sides of a quadrilateral is 2 to 3 to 5 to 7, and the perimeter is 68. Well, 68 is the whole, so just add all those up, and then you'll have the whole part of the ratio. 2 plus 3 plus 5 plus 7 will be 17. And then if that's the sum of that ratio, of the ratio parts, then you can see that we're going to be scaling each one of these up by a particular number. I'm hoping you can work out what that number is. And there's 17 and 18. So we want to ask ourselves, x minus 5 over 4 is c over 3. Does that mean x minus 1 is equal to c plus 3 over 3? Well, what's happened here is I have added 4 over 4 to this one and 3 over 3 to this one. So what we've done is we've added a 1 to each of these. So if we go up to sample problem 5 as a theorem, we can actually figure that out fairly nicely. Okay, so let's go up to sample problem 5. Okay, and so show that A over B is C over D, and A plus B over B is C plus D over D. So if we are adding 1 into this, we're actually going to end up with proportions that are equivalent. So it will work out. So what we really did here was we added 1. So all we're doing is saying add 1 to both sides, and that's a true statement. That just doesn't change anything about the relationships. So we're adding 1, so that's the same as B over B or D over D. And then that becomes A plus B over B and C plus D over D. And so on this one down here, we added 4 over 4, and we added 3 over 3. So because the minus 5 became minus 1, and the C just became C plus 3, we're adding 1 to both sides. So that's legit. Now we're going to try and find the ratio of x to y. So you're going to set up, product of means, product of extremes. Actually, if you want x to be the top, make this the product of the extremes. And x can be the first proportional, a plus b can be the fourth, y can be the second proportional, and c plus d can be the third proportional. Okay, and 21 Okay, you're going to have to go back to a theorem that will let you know that it's called the midline theorem. If you take a triangle, so here's this triangle, and you draw a line connecting midpoints of the two legs of that triangle, you actually split the triangles into proportional triangles. Okay, so this angle and this angle, well, you make a parallel line, and that actually tells us that angle EMG is the same as angle EOF, and EFO is the same as EGM, and so forth. So what that means is that, and also this is going to be half as large as the base. So you'll be able to apply that for both this and this. So you know that the overall, you know that EJ and MG are equal to 42. Okay, and those are in fact the bases of these two triangles. You want to find out what OK is. Okay, well, OF and OK have a relationship of 3 to 4. So you want to figure out what would be the relationship of 3 to 4 for, let's see, OF to the one that's parallel. So that's MG is to EJ. So you're going to figure out how you would split 42 into two numbers that would have a ratio of 3 to 4. Of course, 3 plus 4 is 7, so you could figure out what has a relationship 3 to 7 as something is to 42, or 4 to 7 as something is to 42 to figure out these. Okay, and so OK will be based on half of mg. So that's how you'll go with that. Hopefully that helps.